put it color. Is it me or the door is weird? Okay. Thank you so much.
Please move your step more quickly. This session will be started immediately. So thank you. Okay, now we give our speaker a great ovation.
Hello, Taipei. I'm really happy to be here. With the strange sounds. My name is Cristian. That's me in a football game. I am originally from Barcelona. Nice city. And I currently work at Zendesk. Zendesk is a pretty big company. We are around 1,000 engineers. And our architecture is still mainly based on Rails. First of all, I wanted to comment why we're doing this presentation. Here you have a good reason. As Matt says, performance skills also rose. And of course, the question comes here. Does Rails scale? I need to do it with the micro, I guess, no, for the recording. Sorry. Order. From fact. Okay, better like this, maybe. Okay, sorry. So the point that you are asking yourselves is probably does it scale? Well, I have something to tell you. Here there are a lot of people with a secret. Some of you went to computer science school. Who went? Who went to university to study computer science? Okay, so you know what I'm talking about. You remember the first day? You arrived there to school, you know, with all those nice teachers. And again, everybody that went to college, you learn two things in the first day. Here's a picture of the teacher. First of all, Ruby is dead. Come on, Matt is a very nice guy, but that's the reality. And second one is Rails doesn't scale. It is known. A couple of months ago, programming Twitter was talking about this all the time. I don't know if you remember that super nice gesture that DHH had with TypeScript. Basically, he decided that TypeScript was so bad that it needed to be removed from Basecamp. And he also kind of made a big public event about it. So of course, this caused a flame war. And well, because he is the author of Rails, people started attacking Rails. And the problem that we have as a community is that we are obsessed with the idea that Ruby doesn't scale. It's funny because you check benchmarks, Ruby is in the similar scale of Python. We are a little bit slower, but it's kind of a similar thing. But you don't hear people obsess all day that Django doesn't scale. It's just a thing that was a problem that we have, like a psychological problem in the community. And the thing here is that you know that there's a lot of companies using Rails. All these companies use it at some point of their existence. And for me, the funniest thing is that in all of the speech in Twitter, in all discussion, there's a lot of people that have no idea what they're talking about, but they still write stuff. Like, for example, my favorite tweet was this one. Sorry, I don't have a slide. So basically, someone wrote that Zendesk doesn't use Ruby at all. I've been working 10 years at Zendesk. I'm GTL of Zendesk. I can guarantee you that every day I use Ruby. So when someone says X company does Y, most probably it may not be true. Well, and the other proof I have is Shopify engineering. I think Shopify is kind of pushing the limits of what you can do in Rails nowadays. And every Black Friday, they come back with incredible data of how Rails is able to scale. In this case, they serve 76 million requests per minute during Black Friday. That's pretty impressive. So my point is that Rails scales because it just does. Like, there's people using it at a crazy scale. It's just a fact. It's not a theory. So the question here is why people believe that it doesn't. Okay, I have a possible explanation, but for it we are going to need to do some time traveling. By the way, this is Doraemon, and he will come back to this presentation. But well, let's travel first to the year 2010. This is me. And I was writing my first Rails app. It's been 13 years doing this. And I wanted to add authentication. My app was a movie magazine. I love cinema. And I wanted that some users should be able to, go to a back office, to write reviews, typical thing. Thing is that authentication is a hard problem. Eventually, later I became tech lead for the authentication team at Zendesk, and believe me, just encryption is crazy complicated. But then I was on my early 20s. I had no idea, so I said I'm going to learn about this thing. So I checked, the best sources. I read all the books, and I documented myself very well. And I eventually found this gem called Device, which is great. I read the documentation. I just needed to run a migration, add a couple of lines, and that was it. It worked. My point is that authentication is a hard problem, but for developers using Rails, using Device, it doesn't feel. It feels like something as easy as add a plugin in WordPress. Okay, now let's go back to a time machine. That's me in 2012. I'm very proud of this picture. And then I was the technical leader and chief technical officer of this company called Playful Bed. I was also the only engineer at it, which made all the processes way simpler. And the thing, despite having only one engineer, we were quite popular, so we had to scale. Scaling, again, is a hard problem. So again, I did another very thorough investigation, and I found this gem, ActiveScale. Who here has used ActiveScale? Okay. I read the documentation, and I added this initializer. Require scale Rails. Scale Rails scale, sufficient but not too much. Eventually, as your business grows, I recommend to go scale as much as possible. That's my recommendation after the 12 years of Rails experience. And that's it. Everything was beautiful and nothing hard. Thank you. Okay, not exactly. It would be great, no? So, what if scale doesn't exist? And the thing is that the scaling is a hard problem, and it feels hard. There is no like cheap lunches or free lunches like what you get from Device or from other gems. You need to learn. You need to get some basics of software engineering to make Rails application work at the scale. So the problem is not with Rails. The problem is that Rails is so good that one of the few problems left for you to solve is scaling. So how do you scale? Well, before going into the techniques, I want to comment a few ideas on the presentation. We are going to give just a general introduction. General ideas illustrated with issues that we found scaling to a significant scale. Most importantly, you need to understand that there are no silver bullets. Because every system that performs badly has its own peculiar problems. Yeah. Second, I wanted to comment is why I believe that I'm qualified to talk about this is because of Zendesk. Zendesk, we are a customer support company. So, for example, I don't know, if you go to a restaurant and food wasn't good and you want to make a complaint, if they use Zendesk, you are creating a system, an object in our system. We have over 20 billion tickets, and that was like a year and a half ago. Probably right now is more like 25, something like this. This means that for each person on planet Earth, you could assign them 2.5 tickets. That's a lot. Moreover, the data set is growing a lot every year. Around a third of the data is new. Around a third of the data is created during the last year. This obviously has an obvious impact on our databases. Our relational database is over 400 terabytes. Moreover, in each table, you have some tables that are crazy big, and we have one table that has trillions of objects. Okay. Now, I would like to comment some of those techniques. First of all, one that is very important because you cannot solve a problem that you don't know that you have. So here is where monitoring enters. One thing that I always get when talking about monitoring is that it's expensive. Particularly when you have a lot of data, a lot of traffic, it can be very expensive. There are good news about that. When talking about performance, you don't need all the data. A lot of times, if you take just a part, you can work on it. Sampling works very, very well. For performance purposes, a lot of times, 5% of 10% of the data is enough. And next, once you have an idea of what's happening, you can set error budgets. So I don't know if you're familiar with the concept of error budget. The idea is you decide that this specific endpoint needs to return a 200, 99.99% of the time. That would be 4 nines. Typically, we talk about the amount of nines that an API endpoint works. Okay, that's fine. Imagine I say, hey, my endpoint is fantastic. It has 8 nines, something crazy. Yeah, but 95% of the time, it takes 20 seconds to return 200. Is that okay? Most probably no. So what we do at Zendesk is we set up another error budget, counting the amount of time that it took for an endpoint to return. Here you have a real example. At the left, you have the typical error budget with uptime. Then in the middle, you have the amount of times that the endpoint return in what we define as acceptable amount of time. And at the right, a good amount of time. That's, of course, what is acceptable, what is good is arbitrary. But it's still very useful. It's good to have a North Star to know where are you. And second, you want to be able to track when an endpoint performance degrades. So if you have defined that, hey, this endpoint can take 300 milliseconds and that's acceptable, fine. Because the idea here is that if it suddenly you jump to 700 milliseconds, you need to be able to detect that fast. Okay. Next, we're going to talk about what people think is the key of performance. They are right. But the thing is that I didn't want to talk much about this because I think you have a lot of resources about it. Originally, this talk was called Beyond N+1 because that's not the main point. Still, some very, very general ideas I wanted to give. Use database indexes, please. I was talking 1 year ago with a pretty famous Rubyist at Portland, and he told me, yeah, the vast majority of people I talk that say, oh, Rails doesn't scale, they haven't added indexes to the database. So please, it's the minimum. Then, when you're talking about indexes, you will find that sometimes the database engine won't pick the right index by itself. This happens a lot if you have very, very complex queries or even tables with a lot of data. It can get messy. So please, there are tools in most of database engines called like explain analyze, that will tell you what is happening under the hood. Next, and this one is a technique that is incredibly basic for anybody that is running an application that scales at pretty high level, and it's surprisingly not so well known, is sharding. The idea here is that you have one database, and you should ask yourself, can I divide it? So for example, typical customer of Zendesk, I don't know, domain our own, support.zendesk.com. When someone throws a request against support.zendesk.com, will they want to access data from uber.zendesk.com or whatever, or another customer? No, actually, you want to avoid as much as possible. A lot of use cases would work perfectly well if you divide the data and send it to other databases. What we typically do when you have this architecture is you need each application request needs to be connected to two databases. One that is global, we call it the account database, and another that is sharded, so it has only the data that is relevant for the specific request. Next concept is what I call the greedy selects. That's actually a funny one. Because probably you've all seen these tables that are super huge. They have like 10 text columns. They're too big. But still remember that every time that you're doing a query on Active Record, you're fetching everything. You're doing select star. If you have these very lean endpoints that you return, I don't know, ID and name, you're still fetching everything if you don't use .select. This is a real case that we had with an endpoint that was causing incidents, and we couldn't understand why, because it was an endpoint that returned all the objects of a certain collection, but it was so thin, the response, because it was only IDs. Eventually, we discovered that the person that wrote it originally was not using select, so we're fetching a lot of gigabytes just to return a JSON of, I don't know, 50 kilobytes. And the effect was brutal, as you see, when we just added .select ID. Finally, I would recommend you to focus your efforts on complex database queries. Because those have very high variability. If you check just the medium case or the P50 or whatever, you may think, oh, this query is fine. But maybe if you have a use case where, different accounts have different amount of data, you will find that the P99 is terrible. and some of your bigger customers that most of the time are the ones bringing the most money have a horrible performance. So please check that. And now that we're talking about database queries, I wanted to talk about the Pareto principle. The idea is the vital few. Basically, it's like the 80-20. So 20% of whatever has 80% of the impact. For example, in our case, we believe that 20% of queries improvements have impact on 80% of infrastructure cost. 20% of queries consume 80% of database resources. And finally, 20% of queries fulfill 80% of application needs. So focus on the most used queries and maybe the slowest cases. And finally, some comments are very specific to Zendesk. We are in AWS, and we found that one technique that works well for us is right sizing. So in AWS, you can set up the size of the instance of the database. And we found that we need to be a little bit smart about it. Sometimes we found that typically people think, hey, just give me a bigger database. I'm going to need a bigger boat, like in Joe's, and it's going to work. Not always. As an experience, we found that if your instance is IO intensive, you need to downscale. If the problem is computation, upscale. Okay. Moving on from database. I wanted to talk about caching. I'm pretty sure that everybody is familiar with caching. So I wanted to comment a few techniques that are close to it. One is write-through caching. This is mainly very useful for the normalized objects, for endpoints that return the normalized data. Endpoints that return the normalized data. And the idea here is that every time that you are writing to your normalized database, you should also write into the cache. If you know how caches work, this is all super stupid. If you write everything, you will just end up with a database duplicated. But that's not what we mean. Here we mean is that sometimes you return the normalized data. Like, for example, amount of rubies that live in Taipei. The idea would be every time that a user that is a Rubyist updates location to Taipei, you write the normalized calculation to the caching layer. Like this, every time that a user gets the data, you don't need to make this very expensive calculation of who lives where. You can just return this pre-calculated result. Again, we applied this at Zendesk. We had a side load for one of our main endpoints. And the endpoint as a whole moved from taking, the side load that was added, it was called a lot of times, moved from 40 milliseconds to less than 5. You will be saying that 40 milliseconds, actually 35, is not a lot, but at the scale, it is. Again, this endpoint was being called 50,000 times. Actually, I think that more than that. Multiply for 365 days, that's more than 8 full days of computing per year. Of course, write-through caching and caching in general has trade-offs. You're adding complexity. A lot of times you are duplicating data. There is no one clear source of truth. The source of truth will be the calculation again, but you're not returning that. Caching isn't trivial. And at this point, we return to what I promised. We're going to talk about the Doraemon. So, here in Taipei, who knows who is Doraemon? Okay, that's good. I was spent in this. I made this talk in 6 places, and it's very interesting how Doraemon is more popular or less popular. This is pretty popular. I think the most popular was in Thailand, the least popular in Poland. Nobody knew who Doraemon was. So, still, I don't know to introduce you to him, but you can read this. For me, when I was small, it was fascinating. No? He's basically a wizard. And the best part of him, like the craziest part, was this pocket that he had, you know, like he can fit whatever. Like I put the door because like iconic, but I remember that he once took a boat or something. It's like wild. So basically, you got anything fits there. It's like a land where, you know, space doesn't matter. So it's basically like Redis. Yeah. But beyond that, I discovered that Doraemon is an incredible fable about software engineering. Because each episode of Doraemon has exactly the same structure. So it starts with Nobita crying, having a problem, and asking him, hey, can you give me a machine that will fix this problem? He gets it. And for a while, everything is fine, the problem is solved. But he says, maybe I could use this machine for that and for this. And eventually, he does something wrong, and the problem is way worse. I think like 90% of the episode end with Nobita crying, so it's kind of wild. And why is this relevant? Well, because for a lot of technologies, it's the same. You end up using Active Record to base simple queries, and you end up using it more and more and more in ways that really doesn't make sense until eventually something breaks. You start putting more and more stuff into the cache, and eventually it breaks. So please, use technology wisely. Next is a technology that I think that it will be very interesting for people here in this room because it's not very well known. So it's called cold storage. And you will be thinking, another storage? Why? You're just telling me that put less, use less caching, simplify. Well, the thing is that Zendesk, we have a lot of data, as I was commenting. And this can cause problems. Literally in this table, it's incredibly hard to run a backfill. I tried to run a backfill in a normal way. I started in April, it's still running. It's clear that I will have to find another way. So how to make this better? Is there any way to make those tables smaller? There is. Why not just use different kinds of storage, sending some data out of the relational database? The idea would be that there is data that you don't use that much. For example, most probably will remember what you had for breakfast today. I don't think nobody will remember what you had for breakfast in the 3rd of April, 2003. And that's normal. That's how memory works. And it makes sense for us to copy a little bit that way of working. Here you have how we do this at Zendesk. We have a real example of a mini Zendesk, let's call it. And after some time, we mark the data as ready for archival. We do this, I think, by default, 3 months after a ticket is closed. At that point, we literally remove it from the relational database and we move it to a specialized storage. It's in our case, right now is DynamoDB. Anything that is persistent and key value would work in reality. Of course, this removes a lot of associations and important data that we have to have into the relational database. So what we do is we create another object way thinner so we can keep all those associations. Again, I think this is important for you to know because cold storage or archival is incredibly important in our structure. Literally around 90% of our data is in the storage, is in cold storage. Yeah. Still, there are obvious trade-offs about this. You are having the same collection of data, now divided into different storages. Imagine, I mean, when we talk about making a join, that sometimes can be hard, depends on how big the table is. Well, if you have in data literally different databases, then this becomes absolutely impossible. Imagine having to order records in between 2 different storages. Again, you need to do it in memory. Very hard. So a change in access patterns may be necessary. And finally, now that we're talking about changing access patterns, changing APIs, we move into the product part of making a scalable application. And the most important idea here is product limits. The thing is that you may be thinking, hey, I don't really need this. I know that my system is going to behave. My end users are very polite people, very nice. Okay, no, that's not true. You don't know. So eventually, when you get to a certain scale, you don't know what's happening in the system anymore. I once read that the internet is a system made for bots to talk to each other and from time to time some humans. And in my experience, that's kind of true. I know that product limits may not be sexy, but again, they are basic. Because you will have product limits in all your endpoints. And this is because your application is running on the physical world. And the physical world has real limits. So this is your eventual product limit, the database meltdown. Again, product limits, you can be super generous with them. I don't know, you may be thinking, hey, Cristian, no user in my, I don't know, my recipe creation system is going to ever create more 200 recipes. Fantastic. Put that the limit is 1,000. I guarantee that someone will cross it. In my experience, I found a guy that Zendesk created a ticket, created multiple tickets copying the whole US Constitution, including all the amendments. We didn't have a limit of how big a ticket could be, so this was breaking some of our subsystems. Super important. Next is what I call the incredibly enlarging payload, aka endpoints that return way too much data. And I think if you've been long in a company, you've seen this. You created the endpoint, was really thin, really small. The object had 4 attributes, perfect. And then after 2 months, a product came, hey, can you add this feature, this feature, this feature? Feature creep, eventually you're returning each object 40 attributes. It's huge. This is a problem. The endpoint suddenly is way slower. It's way more complex. Now, sub-feature can break the whole endpoint. And also, it's just a heavy payload. Your front application is to download megabytes all the time. It's just worse. You can control the amount of data an endpoint returns. For example, you can use silos. You can use GraphQL. Then we started with silos, and now more and more we're moving to GraphQL. It's a good solution too. And finally, what I call breaking down slow workflows. You can do this both on the read and on the write. On the read, this sounds like a pretty terrible idea. So I have one endpoint that returns all the data. You're telling me to divide by n2 and just have half of data in each. That sounds bad because obviously you still need to run all the logic, plus all the time in the network, plus or crossing all the middleware. It's just going to be slower by definition. The idea here is that not all data is created equal, and what you care the most is about the user experience. So if you download the data that the user needs to start interacting with the application, and then you asynchronously get the rest, that will be way, way better for them. Finally, on the write, and this is something that I'm actually very happy because I think the Rails community embraced a lot this idea of asynchronous writing. Again, it's a bit like feature creep. You had an update endpoint that updated one thing, and with the time you are making updates and inserts into 10 tables. This is way, way, way slower. So one thing you can do is move it to asynchronous. You just write the most basic part, and the rest is moved to typically a sidekick job, then we use rescue, to do all the rest. This actually eventually is a very nice way to introduce yourself into distributed systems. At Zendesk we do it. At Zendesk, this has become a more and more popular way of updating mainly because right now through acquisitions and new applications that we have been acquiring, has become very, very useful to do it like this. Said this, eventual consistency is true. It can be painful. It's a new way of thinking about systems. Engineers were very used of, I make an update on an endpoint, I expect automatically everything to get updated. When you move to asynchronous, a lot of times you need to change almost all the integration tests because suddenly you need to put sleep 0.5 to wait for the asynchronous update. But surprisingly, for end users, for customers, it's not very hard. One thing that was super crazy, we moved the whole system to asynchronous. Advocates were super scared about it. They were thinking that our customers were going to complain. We'll ping you as soon as we get the first complaints. We GA the new feature. 1 month passed. Advocates came back to us saying, "Hey, when are you releasing this?" None of the tens of thousands of customers attendance had noticed. Asynchronous, as long as we're talking about single unit seconds, is in general pretty fine. And okay, I'm getting to the end. I think the most important thing maybe the mindset that a performance engineer needs to have. It's very simple. You just need to be like Alexander the Great. Well, not exactly. The thing here is that there is a tale about Alexander that fits very well in what I believe are the ways that an engineer, or specifically a performance engineer, needs to think. Let me explain you the story. It was in 333 before Christ, and Alexander was in a war, I think, against the Persians. He was crossing the city of Gordion. In Gordion, they had this legend that they had a knot, a huge knot made of rose meat, made by one of the first kings of Gordion. And there was a legend that the man that would untie it would become king of all Asia. Of course, Alexander had like imperial ambitions. He wanted to be king of all Asia, and he tried for hours, but he wasn't able. Eventually, he took out his sword and cut the knot. And I must admit that when I was a kid, I thought a lot about the story, because I thought, this is so stupid. Like, so what you're saying, like, it's okay to cheat, because you think about the problem like that and you think, well, this is cheating. But then, why is this cheating? Then you realize that somehow you put in the story a requirement that didn't exist. You just need to untie the knot. Nobody said how. I think that we software engineers will fall on this all the time. We have, I was talking in the beginning about computer science, like people that study in college. I think we have this myth of the absolutely normalized database. You just need one. Why I need to cache? And then when you are in the job, you learn that this is not how reality works. And again, in general, we are wary of things that feel like, shortcuts. You in general, you don't need to be wary of that. I mean, you need to be wary of that, but you need to do those things. You need to fulfill the requirements in the end. You need to be bold about that. Most importantly, you need to understand that almost any decision in software engineering is going to be about trade-offs, because there is no such a thing as a perfect system. What there is the system that fits the best the current needs of the business. And again, in my experience, an excessive pursuit of perfection can be counterproductive. I remember there was this meme of the O'Reilly book called Web Development on Assembly, and you might as well commit suicide to like this. And actually, there is a point on that. Like, if you go low level, I can fine tune better performance, yes, but then you may also have zero productivity. The good news is that I think that we are in the right community about that. Ruby community is a community that openly optimizes for developer happiness, because we understand that a happy developer is a more productive developer. And as Matt was saying, it's like about bringing value. Yeah, and actually, talking about Matt, I would like to finish with a quote by him. I believe that the purpose of life is, at least in part, to be happy. Based on this belief, Ruby is designed to make programming not only easy, but also fun. Thanks.
Thank you, Cristian Planas. Thanks for your informative sharing. Now we are going to have Q&A session. Please feel free to ask us quick questions.
Hi, thanks. I'm interested in your thought on when to start thinking about performance issues in the evolution of a system. You're right, the echo is weird. Like, it seems pretty natural that when you're first building an app, don't think about cold storage. I could imagine you saying, though, even on day one, think about using select. So I'm interested in sort of like which of these you think are valuable on day one and which of them are valuable on year 10. And when you know, okay, now's the time to start thinking about cold storage.
Yeah, that's actually a great question. Like, for example, fine-tuning queries, I think needs to be from the start. Like, I don't know, using database indexes, when you design new model, they need to be there. Then, for example, sharding. Sharding actually is one that comes way earlier in my experience than cold storage. Sharding, you want not to start too late. But then, because with sharding, you will need to do a backfill, huge backfill. With cold storage, the same. And this, when you're talking about 500 terabytes of data, can get very painful. So yeah, I agree with you that you shouldn't start with it. Don't start an application and add cold storage because it doesn't work like that. Also, with cold storage, in my experience, you may have to reduce the amount of value you bring to customers because you may have to break certain access patterns, and probably don't want that. But again, I don't know. It's hard to tell you at some point. But you will see that there is a point that certain query doesn't work anymore. It's like that. Like if we wouldn't be using cold storage, then this wouldn't work as it works now for the last 7 years or 8 years. Let's say that architectural changes need to be a last resort, but are still a tool. So, I don't know.
It's good to see someone talk about cold storage and not maintaining a giant database forever. Has using DynamoDB been enough, or have you seen a need to get even colder, like, basically offline storage? At what point would you think about moving to that level? Is it a cost thing, or I don't know, how was your experience been?
This is actually a great comment, and it's a comment I will talk about PPs at Zendesk because I am pitching the idea of getting a cold storage, and I will say, you see, I go to conferences and people ask me about this, but it's, yeah, but the thing is that again, there's I mean, how to say it? Cold storage is something that impacts the product. It's not like sharding. Sharding, that's why I always say that first do sharding and also, for example, sharding is something that nobody at Zendesk thinks much because it just works. With cost comes a lot of decisions like which kind of data goes into cold storage. Because here, something maybe didn't seem very clear, but there is a ticket and there is events. So in cold storage, you are not only putting the ticket. You're putting a lot of data is associated to it. It's a bit like in Elasticsearch that you are saving a huge object of things related to. So here's the same. About this, again, I am a huge fan of the idea of when something gets very cold. So we're talking about, in this case of Zendesk, 2 years, put it into a cold storage. That my proposal that was not accepted was like S3. And the only way to access it will be you download the JSON. You get all the data, but that's not accessible from the UI of Zendesk. Again, but that was only my idea, and I'm proud. I mean, obviously, this works, no, in a lot of ways. Again, depends of product, depends of the company. But yeah, that's all. Of course, if there won't be any other way, that's how it will go. But at this point, we are not, and we're not in that situation.
Okay, this meeting is over. Thank you very much. Let's take a lunch break.